Hello, I'm Sanjana and I have my teammates Ronak and Hardik with me, and we want to talk to you about our TRIPADVISOR project. Basically, what it's about is we're trying to come up with a comprehensive model for all network orchestrating platforms by analyzing dimensional ratings, standardized price ranges, and sentiment analysis of reviews, thus finding out which influences the overall user rating. The idea is to build a model using TripAdvisor, but this is an overall model to help all businesses predict their future trends and know that if they continue on the same path, if what the trend is going to go like, and this can help them remodel their business plan right now. Why TripAdvisor is because it's an ideal example for the kind of companies we're looking at. It bases its revenue model on identifying the best travel and stay options, so they need prediction, and this is a good value proposition in our research. We have 3 GB of data available, 2.5 million reviews publicly available, and it has a variety of data. It has text, numeric, and categorical data. We've got us from Urbana Champaign database, and that's why we chose TripAdvisor. Our research question is we want to find out the factors which significantly influence the overall rating of TripAdvisor hotels. We've used three factors for that: multidimensional internal factors like service of staff, value for money, location of hotel, cleanliness, and room ambience. And we've used sentiment analysis of previous user ratings, reviews, and price range of hotel. And our outcome variable will be the future overall rating. We've done a literature review on this, and we found that a lot of people have already worked on the TripAdvisor database specifically, or even Yelp database, and they've tried to use sentiment analysis and rating, today's rating, to predict future ratings. We found papers very helpful which helped us do our sentiment analysis well, which spoke to us about text cleaning and creating corpuses with Python. Also standardizing values for text-based analysis. We found one particularly helpful which spoke about joint model for text and aspect ratings, which is combining text and individual ratings for sentiment analysis. How we try to model our work differently is by coming up with a decisive predictor model using qualitative data, sentiment analysis on qualitative data, having our ratings as categorical value and price ranges as a standardized categorical value. We started off with 2 GB of data, which was not consistent and it had outliers and junk values. We've converted it to a 75 MB data file. We had individual data files. We've brought it into CSV files. Now we have 60,000 user reviews. The difficulties we faced were they were all JSON files and they were all separate, and we had to convert them to CSV, which meant manually adding brackets at the end of the files to make it convert it to objects, and merging all the CSV files without duplication or data loss. And we had a lot of junk and inconsistent values, which were problems on the way. What do the numbers mean in our database? We ran correlation tests and we found only one weak link, but otherwise positive correlations between every variable. We had correlation of 1 between the overall rating and cleanliness, so we had to remove the entire variable because it was affecting our data. Price ranges were originally from $99 to $999, so we standardized it from 1 to 5 to keep it in unison with the rest of the project. All our ratings are 1 through 5, and the sentiment analysis index is from 0 to 1. We've done text cleaning with R and Python. We've removed hashtags, removed blank spaces, removed HTML links. We've standardized the words, and we've done slang lookup. Sentiment analysis, Indico was kind enough to give us free unlimited access to their API. The code is in Python, and they're great for hotel reviews with 96% above accuracy. They have sarcasm check, spell check, and grammar check. Our data set was unbalanced. We had to rebalance it, so our database was highly skewed at this point of time. We had more than 50% of our database having overall rating as 5, so we used UBSMOT from the library unbalanced, and we got a little more equitable distribution. This is the summary of our old and new database.
Hello everyone. So linear regression is one of the first models which is the first model which we have run. Since the previous data which we had was not balanced, so now we reran this model using balanced data. So the regression was carried out for basically 3 sets of training and testing data, and the split is given over here. After running the regression model, there was a very high there was a considerable increase in the correlation between independent and the dependent variables, as well as combination of independent and the dependent variable. So as we can see over here are the old and new values of correlation and mean square error. So the old value which we have, the value of rooms which was highest previously, went up from 7.74 to 0.80, and the price, which was the lowest value, also increased a little bit. But what we can see over here is the mean square error increased. So that is because since we have balanced our data, the data points have decreased in the data. So which is why since the amount of data is less, the error has increased. So when we ran the multivariate regression model, we also ran multivariate regression model for all the different combinations of test and trend data which we have. So in this combination, we can see that different types of combinations have been used: service plus value, service plus value plus rooms plus location plus price plus sentiment. The highest amount of correlation with which model gave was the one which considered all all the independent variables combined in one model. This was the case beforehand also. We used ANOVA to compare all models with their succeeder, the previous models, and regularization also was run for each and every model where multivariate regression was used, but regularization did not have any significant effect on the model as such.
Coming to logistic regression, we tried multinomial logistic regression initially because of the nature of our outcome variable being categorical, but we incurred issues with having very low error rate, but the confidence interval was very bad. So we decided to go with general linear model, which worked out better for us, and we considered our outcome to be a binary value. Low rating is 0 and high rating is 1. After balancing the data set, all our independent variables showed to be highly significant, and we constructed our model using all the IVs. Our odd ratios, this table shows the odd ratios of all our individual IVs after performing balancing in dataset. Before balancing the dataset, our data was skewed toward overall rating of 5, so our correlation was 0.832. But after balancing the dataset, our correlation did come down to 0.706. This was a downgrade in our model, but our dataset is now equitable.
Now we come on to naive Bayes. We are using naive Bayes to find the probability of the overall rating in which class does the overall rating is present. In the milestone 2, we actually divided our overall ratings into a dichotomous variable, and in this milestone we actually kept each of the ratings as individual value of the variable. So here we can see that the accuracy has actually increased, but by a small percent, but yet it has increased. And this is naive Bayes without the Laplace smoothing. So we apply the Laplace smoothing, and we again see that our accuracy has again increased. Now we come on to decision tree, bagging and random forest. So after balancing our data, we see that the accuracy has actually decreased and gone down to 66.4%. And when we apply boosting to our decision trees, we again see that the accuracy has decreased by around 2%. Now we apply bagging and random forest. So by applying bagging for 250 trees, the accuracy was 61.97%, and for 500 trees it was 61.12. So we can see that the accuracy is decreasing when we apply, add to the trees. We also performed random forests for in the start we performed for 250 trees, and your M was 3. And here we can see that the accuracy is increasing with the increase in number of trees. We see that here in decision tree our accuracy has actually decreased because our data is now balanced, and whereas earlier it was highly skewed towards the rating 5.
So now we come on to the main models of milestone 3, which is support vector machines. So support vector models are basically support vectors are discriminative classifier which are used to define boundaries to separate two or more classes. So basically for our project the ratings are from 1 to 1 2 3 4 5. So we have considered multi-class classification technique. We have run our model using 3 kernels, which are vanilla dot, poly dot, and RBF dot. Vanilla dot is a linear model, and poly dot and RBF dot are used for non-linear model. So now let's see some statistics. So from the models which we have run, we can see that the accuracy is very high for binary models, where we have considered 1, 2, and 3 as 0, and 4 and 5 as 1, basically poor and good as ratings. And in multi-class, as we see that the accuracy goes down significantly because the number of classes increase. But still the RBF model is the best model because it gives a very high accuracy. So in this slide we see confusion matrix of the best binary class, which is the RBF kernel, and we see confusion matrix for multi-class as well, but that is also of RBF kernel. We can see that when the predicted as well as the actual value is 0, our outcome is very highly it comes to 1178, so which is the error is very small. Similarly, in the confusion matrix for multi-class, we can see that as we go down between 1 and 1, 2 and 2, 3 and 3, the error are actually high only towards the both plus and minus 1 ratings, but as they go away the error decreases significantly. And we have also calculated the required statistics: precision, recall, accuracy, specificity, and F1. And over here in this one we can see the 3 curves which are plotted. The accuracy curve plot actually shows the accuracy is pretty good enough, and the ROC curve shows that as it is near the left hand side and it goes higher, the accuracy of the model is actually really good.
Coming to neural network, this is the correlation table for the six models that we've run. The first model is with 1 hidden node, the second is with 5 hidden nodes. We've gone on to 3 hidden layers, 2 hidden nodes with a tangential activation function, then 2 nodes and a logistic activation function, and 2 hidden layers. We can see that all the correlations are pretty good, but the one with the best correlation is with 2 hidden nodes and a tangential hyperbolicious activation function, and the worst is with 2 hidden nodes and logistic activation function. This is a bunch of this is the neural net. This is how the neural network looks for model 1, 2, 3, 4, and 5. But what I noticed with this is there's a lot of the weights are mentioned on the graph, which makes it a little more complicated than it should be, because we are not considering the weights right now. So I found another library which helps me give a cleaner model of this, called the library was developer tools, and this is a slightly better version and a cleaner version of the neural net that we've chosen.
Now we come on to the last part, clustering. We've here used 4 clustering methods such as k-means, hierarchical clustering, dbScan, and model clustering. The thing with our data is that 5 of our 6 variables are actually more like categorical values, and they take only the values of 1, 2, 3, 4, and 5. So there's it's not very easy to find patterns in our plots when we use clustering. So starting with k-means, we performed k-means for with a different value of k, such as 5, 6, and 7. Here we can see that with the elbow function that the curve is slightly stooping after when k is equal to 5, 6, and then after 7 it's going quite a straight line. So now after selecting a value of k, we iterated our clustering algorithm till we got a number of points which are quite similar in all the clusters. We can see here that when we put k is equal to 5, we got the component explained as 76.3% of point variability in the model. We can also see on the top right corner that the number of data points in each clusters, and the sum of squares by the clusters is 65.3%. We again did this by k is equal to 6, and we again run the model a number of times to find the data points in each cluster, and similarly with k is equal to 7. Now we move on to hierarchical clustering. The thing with our data set was that we had more than 10,000 rows. That's why it's a huge data set. That's why we first computed the hclust function on the entire data set, and actually our dendrogram wasn't quite clear. So we randomly sampled our data into three sets of each 50 rows. Then we run hierarchical clustering on each of these samples by 3 methods such as ward, complete, and average. After obtaining a dendrogram for our sample data, we put a cut-tree function so that we get the tree into several groups, and we put k is equal to 7. Now you can see here that we have the dendrogram for the original data set. We cannot see much in this dendrogram. And on the left side you can see the number of data points in each cluster and the mean values of these variables. Now here you can see that that one of the samples and we put a cut-tree function on one of the samples, and we get that there are 7 clusters. Here we can see that the number of data points in each cluster, and again the mean of the variables in every cluster. You can see that as the mean significantly changes in any cluster, the variable is more significantly affecting the model. Now we move on to dbScan. We use dbScan clustering method to group together closely packed points and mark the outliers which affect our model. We used this function knn displot function to optimize the epsilon distance. We found that after many iterations, we found that the distance to be 0.45 and min points to be 105 to 100, and you can see below on the left side the border, seed, and the total points. This plot is since we have more like categorical data, we can see that the plots between every variable such as service value, rooms, location, and price, and except for the one where settlement, which is a continuous variable. Now we again applied one more model-based approach, and we selected density. You can see here that the density of each points in every variable is shown on the plot on the right hand side.
So now we just move on to the last and final step of our model, which is a comparison in CARET using the multiple methods for cross-validation. So in the slides I have used, I'm just showing you a method of boot and repeated CV. I have performed CV as well. So from this slide it can be very well seen that we have I've mentioned mean and median of accuracy. So the maximum mean is of random forest, followed by SVM of RBF kernel, and these are the plots of, there's a box plot and a dot plot which shows the accuracy and the kappa level. Also, using repeated CV, we can see that the accuracy changes a bit, and it tends to increase towards decision trees, boosted trees, bagging, random forest. It all goes up slightly, and these all become pretty more accurate using a repeated CV. And these are the plot for a box plot and dot plot. Thank you so much.
Thank you so much.
We would like to thank our Professor Vanessa for all her help and guidance through the process.
Yeah.
Thank you.
Thank you. Stop.